This is our basic control circuit. This is what we call a 3-wire control. I've got a lesson on the difference between a 2-wire versus 3-wire control. Spoiler alert, it's this holding contact here. But again, this power comes through, goes through the stop, which is normally closed, comes to the normally open push button. You push that down. M coil, that's not the motor, that is a coil, energizes, goes through the overloads and up. At the same time that M coil energizes, these contacts here close and it holds in, so that if I let go of the start button, this will go all the way through and I'm good to go. So we have our power circuit up top. We have our control circuit here. Now these two guys have to link somehow, and there's two ways we can do that. This, generally where we get our power from for the control circuit, is off the power circuit. There's two ways we can do that. We can do either full voltage control or use a control transformer. So let me show you what I'm talking about. Here's full voltage control. So let's say that this is like 120, 120, 120, and this control circuit down here is going to be 208 volts. Pretty standard. You'd have this coming between these two lines here. You have 208 volts. The difference is, or not the difference, the thing you have to make sure is that this coil can handle 208 volts, which is possible. But what I would suggest is probably doing this, is throwing a control transformer. So if you have 208 volts, or even if say you've got 600 volts here, you can step that voltage down to like 120. You can go down to 24, 12 volts. So that's what we put the control transformer. So if you open up a combination starter, oftentimes you're going to see a control transformer in there. So that's where we get the power from. We take the power from the power circuit over to the control circuit, and so they're all interlinked. Now we grab it off of any two lines after these fuses, right? We do it after the fuses because we want to make sure that this control transformer is protected. If it shorts, it'll blow one of these two fuses. There we go. Now we want it after the fuses, but not after the contacts, because these contacts are normally open. If we had the power after, then the power would never get through because we need this guy to close that guy, so it just wouldn't work. All right? Now, I talked about how these guys are connected. These overload heaters here are actual like a bimetallic strip or a solder pot. They're physically attached to these overload contacts down here. So if the heaters open up, like if these guys trip, then it's going to open up these normally closed contacts in the control circuit, and the whole circuit shuts down. This M coil de-energizes, everything shuts down. Same thing, if this M coil energizes, and I believe I did a little video on the forward reverse last week, and I talked a little bit about this, but if this energizes, these contacts here will close. Okay, so that's how we close these contacts. So if we push this down,